Welcome all to this webinar on MVIS with Kubernetes. In this session, we are going to learn how easy it is to deploy MVIS in Kubernetes cluster with a in-memory data store called Redis. My name is Amir Okre, a cloud enthusiast and working as an architect in Rocket. I'm excited to take you in this journey of MVIS with Kubernetes. For this webinar, I have used following resources. Please feel free to check out as they provide pretty good insights into the world of Kubernetes. The entire source code used during this demo is available at our GitHub repository MVIS Kubernetes. I have used Terminal Emulator, CMDR, but feel free to use any terminal editor of your choice when you run through the demo samples. For this demo, I have created a simple two-node Kubernetes cluster. We are not getting into the part of setting up a Kubernetes cluster in this demo. Please refer to the resource section for detailed steps in setting up the cluster. Let's see how we can deploy MVIS into the cluster. We have created a project called as MultiValue University in GitHub. This project contains a repository called MVIS Kubernetes. In this repository, we have created sample examples and documentation of how to deploy an MVIS into the Kubernetes cluster. One has MVIS Admin, YAML file, MVIS YAML, and Redis YAML. More on this YAML file and what they mean into our overall solution, we can see as we go further in this demo. We start this thing by cloning the repository in onto our local desktop by using git clone command and navigating to the project MVIS Kubernetes. I have used over here the VS Code editor in order to display the source code of this repository, but one can use any of the other editors of their choice to see the YAML files. So let me start the VS Code editor. So once we have opened our source code in the editor of our choice, let's navigate to the section Hello MVIS. It contains three YAML files. One is MVIS, MVIS Admin, which is our administrative console, and the Redis, which is the actual in-memory data store. So let me start with Redis. As we have highlighted in the previous, there were deployments. There is a similar kind of called as stateful set. The difference between deployment and a stateful set is that it maintains the order in which the pods come up. They guarantee that the pods get the volumes, and it's specifically important that when we have multiple pods in a deployment, they get their IDs every time when the pod dies or when the pod is being again recreated. In case of deployment, the pod gets a new IP address and also the order are a little bit different. So in case of Redis, like a full-fledged Redis server, where there is a concept of master and client, where the data is being replicated, stateful set comes into much more usefulness. For our use case, as we have a single Redis server, I have just created a stateful set. I have said over here that I need a replica with only of one, and I have said I need a pod, which name is Redis 32 Alpine, and the arguments passed to it. I'm exposing the container of this Redis server at 6379, and that is the same one. If you look further into our service object, we have again mapped to it. So our service object is also listening on to the 6379, and our pod is also listening on 6379. So any communication happening to the Redis server on 6379 first reaches the service object, which then delegates it to the stateful set pod, which is listening also on 6379. So how does one deploy this thing? If I have to go to the directory where I have this YAML files, I'm going to go to the deployment followed by hello MVIS. Kubernetes has provided us simple commands. One of them is kubectl create -f, and I'm going to give the redis.yaml. Once I execute this command, it will create a stateful set and a pod named a Redis. So now let me verify whether the pod is being created. And we should be able to see a Redis pod which is running. It is running and it's with status 1,1. Now we'll go into the details of MVIS admin. Again, we have a deployment object. The metadata is a common pattern which is being used across all Kubernetes objects. This provides meta information about the Kubernetes. So in this case, I have named the deployment called as MVIS admin. This metadata section is for the deployment. It's followed by the spec section. In the spec section, we specify how many replicas we want for it. So for MVIS admin, I have chosen 1. I have followed by the selector match labels app MVIS admin. So this construct of selector match labels will be searching for pods with name MVIS admin, and that will be the ones which will be controlled or replicated by the replication control. So this is a way of informing that I need a replica set, and in this case I want to replicate the pods which are matching the labels MVIS admin. This is followed by a template section. So in this case we are defining actually the pod. We have a metadata with the labels. Again, we are naming them as MVIS admin. So as I highlighted before, MVIS admin is the name of the pod, or the one which will be used to select the pods which are created. The spec section contains containers. As we have only one container over here for this example, this can contain multiple containers. Have you seen with the hyphen over here? Our example, I'm going to stick with MVIS admin, the name of the container. The important part is the image. So we have a Docker image called cmadmin. In one of our sessions of Docker container, MVIS with Docker container, one can see how can one load these images into the Docker repository. We have the image pull policy followed by its container port. So we are exposing 7077 as the container port. So any communication will happen through the 7077 port. We pass in a bunch of Java options to our MVIS admin. So we have two modes, WebD and MVIS mode. So we are starting the MVIS admin in MVIS mode. Important part is the Redis host, which is having the name Redis. So if you remember, I have created our Redis stateful set with a name called as Redis. So in that way, we are able to communicate to the Redis host data server or in-memory data store. This is followed by service object, which we have named as MVIS admin. Important part is I have made it as a node port. Now one may wonder, what is node port? So node port, the type of, in case of a service object, indicates that you will be getting a port from one of the worker node on which this pod gets deployed. So 32500 is the port which I'm exposing for that worker node, and your application or your MVIS admin will be able to reach on it. In node port with 32500, we have mapping it to 7077. That is the significance of this construct of port, target port, and node port. Now let's see how we can deploy the MVIS admin. So I have again kubectl create -f MVIS -admin.yaml. This would be creating a deployment of MVIS into the system. So if you see over here, we have a deployment object created and we have a service object created. How does one verify? One can run kubectl get deployments. This will show us the deployment which we did for MVIS admin. One can see whether the service object is been created or not using the command kubectl get svc. So this will show us that we have an MVIS admin which is of type node port, as I already highlighted, and the external port is 32500 will be routed to 7077 in the cluster. So let's see how this application looks on the browser. Important point is that you see over here that I have opened it at 32500 port, and that is the name of my worker node machine. So it's a physical or a virtual VM which is acting as one of the worker nodes in Kubernetes. So let's say over here admin, and logged in as an admin, and I am able to see the admin console of MVIS. In this way, we are able to deploy the MVIS admin as a pod into the solution. As the MVIS admin is deployed now, let's turn our attention to MVIS, the backend server. The constructs are similar, that we have a deployment object. We have over here, say, instead of having one replica, we have set two replicas over here. So we're going to have two pods of MVIS server. Again, the concept of images. So in this case, it's a Docker image is not CM admin, but CM. And we are exposing the following ports: 7870, 717, and 7871. So these are the three ports of the container of the application which we are exposing as container ports. The constructs, again, passing the Redis host as in the Java options. This is followed by the service object. I have created here a load balancer type just for differentiation. I just want to show you how one can have the different combinations, node port and load balancer. There is no restriction on an MVIS to also have a node port, so one can use even that. I have exposed the endpoints, the service 7870, 717, and 781. The REST port is the 7171, so you can get your REST request on 7171 port. There is a monitor port on which we can get the monitor information. We can see the performance of the application throughout. And then we have a 7870 port, which is our UOJ port. So all of these things are being exposed as a service object. Let's see how we can deploy the MVIS server. Now, the same constructs, create -f, and here I'm going to specify mvis.yaml file. What one expects is that we'll be creating a deployment and a service object. Great. Now we have an MVIS being deployed along with MVIS admin. I'm just referring through it. And we have it. So what we see over here is we have MVIS deployment 2 by 2. So we actually deployed two instances or two pods of MVIS. They both are up to date and they are available. One can see it again by running kubectl get pods. The good thing is both of these pods, MVIS and MVIS admin, now are communicating through our Redis server. So any configuration information which we store in the admin is being available to the MVIS system and vice versa. So let me pull up the MVIS admin. I'm just going to log in up and admin and user and password, and we see MVIS running. The important part over here is you have to specify the host name as MVIS. That is the way we have exposed our MVIS using the service object. We have named our service to be reachable using MVIS. So that is the one which we should be specifying for MDS admin. Now to show you, I have already configured an account over here. One can add as many accounts as possible, and if I run through this, if I have a test connection, and this is reachable. So this account is actually a machine where our database is running. This can be a machine which is reachable from the Kubernetes cluster. The database is not running as a pod in the system, but it's kind of a physical machine or a virtual machine, and on which the database process is running, and we are connecting to it. In this way, we can see both the MVIS and Mds admin being deployed in the Kubernetes cluster with a simple YAML configurations. Please refer to the source code again in the following repository, MVIS and Kubernetes. Here are some of the other MVU courses which I would highly recommend to check out. MVIS with Kubernetes, containerization and orchestration. In this, we would understand what is the need of orchestration and benefits of it. MVIS with Kubernetes, setting up and deploying sample app. In this, we would be experiencing how to deploy a sample app into the Kubernetes. MVIS with Kubernetes, setting up MVIS with Redis server. Here, one would deploy MVIS in Kubernetes along with the Redis server and in-memory data store. MVIS and containers. How easy it is to run MVIS as Docker container. And finally, MVIS in prominent cloud providers like Amazon AWS and Microsoft Azure.